Good morning, class. Today we are going on to section 5.3 of your A Maths textbook. Okay, section 5.3 of your A Maths textbook. Now, you are expected to read page 109 to 117 of the textbook yourself. Okay, because this is the way to get it done and you have to understand it yourself. Okay, so read page 109 to page 117 of the textbook yourself. Now, I'm just going to explain the main things that's in this section 5.3. Now, 2x equals to 150. This is written in the index form. Now, how do we write it in the logarithmic form? Is we put the base here, the power here, and the answer here. Okay, can you see the base here, the power here, and the answer here? Okay, so this is called the logarithmic form. Okay, now the index x is known as the logarithm of 150 to base 2. That means this is known as the logarithm of 150 to base 2. Okay, alright, now for a logarithm to be defined, okay, if we want to have log ay to be defined, y must be bigger than 0, and this base a must be bigger than 0, and a must not be equals to 1. Okay, you can find this on page 110 of your textbook. Okay, then I'm going to introduce to you two common logs. Okay, now if you have log to base 10, okay, log to base 10, it is called common log and is short form LG. On the calculator is given by the button LOG. Okay, now next, if you have log to base E, we know that E is a special number, 2.718 and so on. Okay, we short form it to ln, Ln. It's called the natural log or the Napierian log. Now, usually we just call it the natural log. And on the calculator is written as Ln, the button Ln. Okay, now, how do we write in common log and natural log form? If I have y equals to 10 to the power of x, we will have LGY equals to x. Y equals to e to the power of x will be ln y equals to x. This one just means log base 10. This one just means log base e. Okay, so this is how we use the common log and the natural log. Alright, now I'm going to move on. Now class, for example 10, 11 and 12 on page 111, you are to read through it yourself because they are very simple examples. Okay, now one thing that I need to let you know is what is found on page 112. Log AA is 1 and log A1 is 0. Now I will give you a numerical example. What does this mean? Okay, what does this mean? For example, if I have log 2, 2, 1, it just means 2 to the power of 1 is 2. Okay, now log 3, 1 is 0, it means 3 to the power of 0 is 1. So if this can be 2, this can be 3, this can be 4. Okay, this can be anything. Alright, okay, because anything to the power of 0 is 1. Okay, anything to the power of 1 is the anything there. Alright, so this is a numerical example. Okay, now I'm moving on to example 13. Okay, let's look at example 13. Alright, example 13 says, without using a calculator, evaluate this. Now, we all know that log 66 is 1. 2 times 1 is 2. Okay, and ln E is actually log EE. Now, if it's log EE, it will mean that it is 1. Okay, so 2 minus 1. Log 5, 1 is 0 because log A1 is 0. Log to base anything 1 is 0. So log 5 1 will be 0 over here. Okay, now that will conclude your example 13. Next, I'm going on to the power, product and quotient law on page 112. Now, these three laws are actually very simple to apply, but it may look very frightening in the beginning. Okay, now if you are interested, you can read the proofs on page 113 itself. What basically it means is that if I have log a x to the power of r, I can bring the r down to the front. Okay, then if I have log a x times y, it means log a x plus log a y. Log a x over y means log a x minus log a y. Okay, these three laws can be found on page 112. Alright, so take a look at these three laws and I'll teach you how to apply it in the following examples. Okay, now example 14, 15 and 16, the solution in the textbook are very clear, so I want you to read through it yourselves. Okay, I am moving on straight into example 17. Okay, example 17 says, express this whole thing as a single logarithm. Okay, now I'm going to explain step by step. 2, I can bring it up. Okay, because this is the same as bring it down, so I can bring it up as well. Half, I can bring it up here. I'm using the rule okay, you can move forward, you can also move backwards. They are equivalent. Okay, they are equivalent. Alright, so one thing I need to tell you is this. After you bring out 3 looks like the odd one out, but don't forget 3 is log 10, that means common log 10. We always add this if we want to multiply by 1, because log 10 is equals to 1, so 1. Why do we do this? So that we can bring this 3 up here. Okay, then this is minus, minus means divide, plus means times. I combine them, and finally I can use it to simplify it to a single logarithm. Okay, this will be used to express it in a single logarithm. Now, one thing to take note is that the 3 laws can only be used to manipulate log with the same base. Realize that all these are base 10. Okay, you cannot use it to do it for different bases. Okay, now what if the things are of different base? Then we will have to change it to the same base, which brings us to page 115, the change of base law. Okay, the change of base law. Now, there are 2 laws given on page 115, but the second one is actually derived from the first one. Okay, now let me go through the first one here. Don't worry too much, I will give you numerical examples for you to see. Alright, now if A, B, C are positive numbers and A not 1 and C not 1, then log AB is the same as log CB over log CA. Okay, that means you change it to the same base, B put on top, A put below. Okay, you change it to base C. Now, why did I say that the second rule is from the first rule? You just have to take a look at this. If I change it to base B, it's a common base, change it to the same base, B on top, A below. But log BB is 1, therefore it's 1 over log BA. So this is nothing fantastic, it is just that it is derived from this part here, just that we change it to base B. Okay, I repeat the change of base law. You change it to whatever base you want. You put the B on top, you put the A below. We change it to the common base. Alright, now I'm going on to example 18. Alright, example 18. Okay, now I write the change of base law here so that you can refer to it. Okay, now log 25, they say you are supposed to write this in terms of A and B. Now log 25, if I change it to base 3, I will put 5 on top, 2 below. Now log 35 is B and log 3, 2 is A, so I replace, so it's B over A. Likewise, this one, I change it to base 3, 2, 5, 0, and 9. Now, we do prime factorization here because they want it in terms of 2 and 5. Okay, so we do it in terms of prime factorization. Then, I use the rule times, so it becomes plus here. Okay, I bring down the 3 and so on, but log 3, 5 is B, and this is A, so I'll get 3B plus A over 2. So this is in terms of A and B. Alright, now if you need to pause the video to take down notes, please do so. Okay, now I am going on to the last example, and that is example 19. Okay, for example 19, they say, show that this is equals to 2. So I have this. Now, usually we change it to either LG or LN, log or ln. Okay, it's up to you, but we choose log when there are numbers and not E. Alright, so LG, same base, A, 7. LG, same base, 49A. Now, you will realize that 49 is 7 square. So, LGA and LGA cancel off. 2 you bring down, 2 log 7 over log 7. Log 7 cancels with log 7 because they're the same value. So, we will show that it is equals to 2. Alright, so this is your question for example 19, part A. Now, let's look at part B. It looks a little bit long, but it just makes use of the rule that we have learned so far. Okay, now we have this, we are supposed to show that it's log 3, 2. Now, this. So I change to base 3. I change to base 3 as well. Okay. Then I write 9 as 3 square. This as 3 to the power of half. I am using the laws of indices. Okay. Then I bring this 2 down. I bring this half down. This is what we get. Okay. I rewrite this in this form. Now divide by half is the same as times 2. So I get this one. And log 3x minus 2 log 3x is just minus log 3x. I bring the power up. Okay, I'm going to simplify because it's minus. It means divide according to the division rule. Okay, so square root of 4x squared is 2x over x. X and x cancel. I will get log 3, 2. I will get log 3, 2. Okay, so it's shown. Alright. That will be your example 19 on page 116. Now, I have gone through all the examples already, and I'm going right now to assign you homework. Okay. Now, these 2 sets of work are to be done. One set in the notebook. These one are all basic questions. I will not go through. You will just try it in your notebook. Now, this set of work over here must be done on the foolscap paper and file it into your Max file. Okay, the first set to be done in the notebook, the second set will be done on the foolscap paper, and this one I will not go through because it's relatively simple and you can check the answer with the back of your textbook. Okay, now let's move to 8A. Now, class, please ensure that you have done your homework before you check the answer. Okay, don't just copy it from the video. Alright, let's look at 8A. It says, express y in terms of x for each of the following equations. So, I do it this way. I'll bring the x over. You know that ln is base e. I write this. Okay, then I manipulate it such that y is the subject. Y is alone on the left side. Okay. Now, part B. Part B is the same thing. Now that is LG, that means it's base 10. Okay, this is the power, so it goes to show that it will be this answer. Okay, now part D. We will move it this way. We know ln is base E. Okay, we leave the y here, we minus x. That will be the answer to 8D. Alright. So please check your answer to make sure that it is correct. Okay, 9A. 9A. It says, find the range of values of x for which this thing is defined. Now for this thing to be defined, this inside must be bigger than 0. Remember our quadratic inequalities, we draw bigger than 0 means I want the on top one, so it's x less than 0 or x bigger than 2. Okay, alright, so this is the solution to 9a. Now for 9b is slightly more, but it's not very difficult. Okay, now you will realize that x is here and x is here. According to the definition, okay, according to the definition, this here must be bigger than 0 and not equals to 1. And this thing here must be bigger than 0. So when I do this, I'll get x bigger than 3. Now don't forget, we are solving this and it must satisfy both conditions. So I'm going to draw a number line to show the intersection. Now for x bigger than 0 and not equals to 1, I use the red one. It goes this way and you cannot have 1. For this one, x bigger than 3 is this way. Now everybody can see that the intersection is actually from here. So the final solution should be x bigger than 3. Okay, because there are two answers here and we must take the intersection of the two answers. So that will be your 9b. Okay, I'm moving on to question 10. Question 10 is rather simple. They say evaluate x over y. So I put it into index form and then I will evaluate it. Okay, I put it into index form for part B as well, and I will just write this one in terms of A and B. Okay, so for question 10, we just need to write it into index form and then we will do accordingly to get the answer. Okay, now I am moving on to question number 12. Express each of the following as a single logarithm. Okay, question 12 makes use of all of the log rules. Okay, alright, now I'm going to show you here. Bring the power 2 up, power 3, simplify, minus means divide, combine, you will get log A 27 over 50. Okay, so this is just applying the rules. Likewise for part B, we apply the rules. Remember 3 or 2 or 1, whatever value it is, you times log AA. That means log 10, 10, log 3, 3 or whatever is all equals to 1, so that you can bring the 3 in, become cube. When it is plus, it means times, so you get log A 4A cube. Alright, so this is something that you must know. Now let me just reiterate. Even if the number is 4, you just put log AA. 4 is equals to 4 log AA. Or 4 is also equals to 4 log 5. All these are equivalent to 1. This is one technique that all of you must learn. Okay, this is one technique that all of you must learn. Alright, I'm moving on to part C. Part C looks very long, but part C is very simple because all of them are of the same base A. So I'm just going to bring the 2 up to become square. Then I manipulate, I will get log A64. Okay, log A64. Alright, look at the steps. It's not difficult, it's just that it's a bit tedious. Okay, now for part D, same thing. I bring in the powers here and then square root means half. I simplify. Square root of 36 is just 6. So I will get log A6 for the answer. Okay, log A6 for the answer. Okay, now question 13. 13 is show that part A and part B. Okay, now this is a very long one. I call it left hand side. I bring in all the powers. Okay, I simplify, I get this. 8 over 27 is 2/3 cube. You bring the cube down, you get this, and we have shown that it is equals to the right hand side. Okay, now this notation of logarithm may be very new to all of you. That's why all of you are a little bit frightened. But the more you do, the better you will get. Okay, so do not be frightened about the long-winded stuff. Just bring in, do accordingly according to the rules, you'll be able to get the answer. Okay, now I'm moving on to 13b. Now 13b, as you can see, all the bases are different. If all the bases are different, you change it to the same base, log, or ln also can. Okay, now log 27, log 2, same base, top, bottom. Okay, same base, top, bottom, same base, top, bottom. Now then I'm going to put it in terms of the powers, okay, so that I can bring the powers down. Now if I bring the powers down, I'm able to cancel most of it, and what is left is this. So when I multiply these three numbers up, I will get 24. I will get 24. So basically we just change it to the same base, and after that we can do some manipulations and we can get the answer 24. Now though question 14 is supposed to be challenging, but it is not. I'm going to show you how it's going to be done. Okay, first we write all this into index form. Call this equation 1 and equation 2. Equation 1, I can rewrite it in this form. Equation 2, I can write 8 in terms of base 2. Alright, now because these two are y's, okay, before that, how did I get this particular form? Y is this, 2y is this. I bring the 2 over, I use loss of indices, it becomes 2b minus 1. 2b minus 1. Okay, now then all of you take a look down here. This is y and this is also y. I equate both, I equate the index, I have shown what I'm supposed to show. Okay, now let's take a look at 14b. 14b is also very simple. We just write it into index form. Okay, now after that you write it to base 3 and we write it in this form, and we use the rules of indices a minus 3b. Now the questions say that this is equals to c, 3c. Alright, and they say to write c in terms of a and b. What you need to do is just to equate the powers. You will get c equals to a minus 3b. Alright, so you will get the answer c is equals to a minus 3b. Now I finished the whole of section 5.3. I hope you can understand clearly. If there's any time that you want to replay the video, please feel free, and please copy down the answers. Okay, now bear in mind, I will not repeat all this when school starts, so you have to get all these concepts into your head. Okay, thank you class.